So in these problems, we're asked to determine if these things are improperly constrained or completely constrained, and if they're determinate or indeterminate. And so the what we need to do is, in these problems, we need to first kind of sum up. We need to count the number of members, count the reaction loads that we are unknown, and can count the number of joints, and see if m times r is greater than, less than, or equal to twice the number of joints. So in the first case, we have this one, looking at this one, and what we find here is that this one has m plus r equals 2n, so we know that it is completely constrained. But it's improperly constrained because you can see that this section here, so there's a pivot point there, and there's really nothing. This load here is not acting to counteract the load here. So in reality, if this was actually a riser, a kind of wire or something here, this thing would rotate slightly down, so then that would move that way. But because it can move, it's not a rigid structure, and that's why it's improperly constrained. Now, if we take this member and move it up here in the second case, we have the same equation. We have the same numbers here, but this time it is actually determinate. And that is because now this structure over here will carry this load, and this is basically a free-floating structure that we could actually just get rid of if we wanted to. Because if we actually put any kind of load on here that has any vertical component, then there'd be a problem, and this would not be. It would be then improperly constrained. And in the final case, we actually have a member here, so we wind up with 17 members, and so m plus r is 21, and that's greater than 20. So this one is indeterminate and completely constrained.